Hello everyone, good afternoon. My name is Rion Benoy, register number 15BCB0029. Right now, right here, I'm going to explain what my idea is for the Idea 2020. It's not into working, it's just into research, and it's a very interesting idea, very plausible, and a thing of the future. For a guy, actually for a human being, I believe this idea is quite important for our future, and allow me to pitch the idea. Yeah. Okay. It's the internet of nano things instead of it's internet of nano things. Now, before we get into internet of nano things, I am not going to go into the short form of internet of nano things. So let me basically start with nanotech and nanoparticles, nanotech. Let me emphasize on the importance of nanotechnology today. I mean, imagine these microchips, nanochips, everything. It's so powerful. It's influenced everybody today, and it enhanced technology in, I don't know, 18 times, 20 times. Doesn't matter. It just enhanced technology, and it was never the same. It just changed because of the nanotechnology. Okay. Yeah. So as I was saying, the importance of nanotechnology. Now we know the importance of Internet of Things, IoT. How much IoT has influenced our lives. It is a thing of the future. Before artificial intelligence, of course. So now imagine if we incorporate Internet of Things in nanotechnology, like nano things, nano materials, and nanoparticles. Once again, let me emphasize on the importance of nanotech and IoT together. Let me just read a statement of what nanotechnology promises us, and I'll go to IoT, and then I'm going to combine them both with my idea. So, just nanotechnology promises new solutions for many applications in biomedical, industrial, and military fields, as well as in consumer and industrial goods. I mean, that's not even the entirety. Okay, yeah, as I was saying, yeah, nanotechnology. It's what I read out is nothing compared to what it actually is. Words can't express how or what it did. Now, nanotechnology is enabling the development of devices in a scale ranging from 1 to few hundred nanometers. Okay, now that is like at this scale, like nanomachine is defined in the most functional unit. So that's the gist of nanotechnology, how it works, and like where all the applied. Let me give you an example of where nanotechnology is applied. There's a project called purification of water using nanoparticles. It uses AgNO3 nanoparticles along with some enzyme from a bacteria. I am not quite sure of the name of the bacteria, but it is used from an extract of the bacteria, combines it with the nanoparticle of AgNO3, forms a hydrophilic layer. It allows water to seep through, but it's hydrophilic, and it helps purification of water. It has an affinity for other kinds of particles, so whatever is there in the water just gets sucked in. Now that's a high progress in the future, if you ask me. Now, Internet of Things, as you all know, is connection of any half-living, fully living, or non-living thing to the internet, and it functions like you have given it a brain or whatever, or with a lot of how it works. So my topic is Internet of Things, and right now I'm going to give you just the gist of it. For example, let us take a an example like, okay, a suit or something you wear. For example, okay, yeah, a shirt like this, any body shirt, which it actually helps, has a lot of functionality purposes and all that. Now let me get into the concept of that, the architecture. For example, the network architecture. There are intra-body networks and there are interconnected offices. For example, there are nodes in this, in my example right now, there are nodes in this wearable item, wearable device, the wearable IoT. Nanosensors and nanoactuators deployed inside the human body are remotely controlled by microscale and over internet by external users such as healthcare providers. That's how this IoT works. And now nanoscale, that's where nanotechnology comes in, and together it forms the internet of nanotechnology. Also, the nanoscale is a natural domain of molecules, proteins, DNA, organelles, and major components of cells. Now, that the nanoscale extends up to DNA and proteins. That's what it says. And you can, if you can control the nanoparticles or nanostructures using some form of programming with network access, with majority of sensors, with various computational processes, all together a body of network around the planet, connecting each and every one of us through this material, through this shirt. You can achieve a lot of things. For example, suppose you have pulse sensors or body temperature sensors. Depending on the temperature increase or any pulse fluctuations or any irregularities, the information is sent across the network to wherever the destination is. Let us say the destination is in a hospital or whatever. If an old man is wearing the suit, that information is sent to the hospital, and the hospital will have an analytics. Of course, in the future they should have an analytics to process the information received, and after the information is received, they can process it and they can come up to a conclusion, and they can actually take precautions 5 to 10 minutes earlier. Even better, they can actually predict what's going to happen to the patient even before it happens, and that is quite amazing if you think about it. This my idea, this suit with this shirt, if I call it unicorn. That's just a fancy name. It's kind of like a universality incorporated in university incorporated in a wearable device or wearable structure. Now let me get back to this internet of nanotechnology. The intelligence is incorporated in nanotech, right? So with the incorporation, the 6 characteristics of IoT is, first is sorry about that. So yeah, the first component which I'm going to talk about is intelligence. Intelligence, connectivity, dynamic nature, enormous scale, sensing, heterogeneity, security, energy, expression, safety. Okay, yeah, these are the characteristics which I have gathered, which is very important. Okay, intelligence, of course, like intelligence is computations. Wait, intelligence, of course, like in my example, intelligence, you find it on the suit. It sends information to a processing center. It can be both inside over here, send it to the cloud, or any other centers where they actually process it and compute it and get the information and send back for actuation. Any response by any help with the suit, it does. Now connectivity, as I mentioned, is a whole network connectivity. It can I'll explain the network architecture of this. As I said, first mentioned the intra-body networks, like it's between the sensors, and it's kind of like, what do you say, it has like two different ways, two different methods. One is in this material, the sensors, the connection between the sensors. If for example IoT has this characteristics of self-adaptability and self-configurability, that means if there's any sensor which doesn't work, then the IoT device, the IoT system will have to replace that with a with a node or with a sensor of similar kind of function. So it does the same thing, and also it not only ensures the communication of sensors between like just inside this material, it also tells us that it can be sending networks to another body, another human, and another person with the same structure on them. Like for example, if the person has some deformity and he can't function exactly like a human, for example a person with any disorder, he can't tell anything, he can't communicate, such a person, and this actually helps. It can send that information to them, and they can sense, okay, what is wrong with the person, or what is going is something going to happen, is he trying to tell something. That is one form of network communication. The next one is interconnected office. It's what I mentioned, like a person is connected to a server or the cloud, and for that person, and analytics takes place on like about him over there in that allotted position. Yeah, then I'm going to mention the components of these networks. Is okay. So what we have is over here is nano nodes, and they're the smallest and simplest nano machines. As I mentioned, the node sensors, they also they're able to perform simple computation, have limited memory, and they can only transmit over very short distances because of their reduced energy and